Right now, adversarial actors are siphoning petabytes of encrypted traffic from global data centers. They are pulling financial records, diplomatic cables, and corporate intellectual property out of secure networks in massive, silent volumes. This creates a strange logistical burden. These actors are spending millions of dollars on server farms and cooling systems just to store data that looks like randomized noise. At this moment, they have no way to actually read what they've taken. This is the harvest now, decrypt later strategy. The goal isn't immediate access. It's a bet that the processing power required to decode these files is finally within reach. The cyber war happening today is less about immediate sabotage and more about a massive, calculated stockpile for a future capability. Analysts have a specific window in mind for when that stockpile becomes readable, mid-2026. This timeline identifies the Y2Q threshold. It marks the point where quantum computing is projected to reach the scale necessary to bypass current encryption standards. Because of this countdown, data sitting in an enemy vault today is effectively on a timer. It isn't permanently safe. It's simply waiting for a computer powerful enough to run the necessary algorithms. This means the long-term privacy of our information is no longer a matter of choosing the right code, but a factor of how quickly the hardware matures. To see why that hardware matters, we have to look at RSA and ECC encryption. These are the two mathematical pillars that secure nearly every digital interaction on the planet. Both rely on prime factorization. To bypass a massive compound number acting as a barrier, computers must find its two specific prime factors. For a classical supercomputer testing factors one by one, this brute force nightmare would take thousands of years per file. Our current digital security is built on the assumption that this specific math problem is simply too time-consuming for any machine to solve. We aren't protected by a physical shield, but rather by a temporary bottleneck in our raw processing power. The mid-2026 arrival of advanced qubits changes the nature of that math. Qubits use quantum mechanics to evaluate all possible mathematical paths simultaneously. While classical machines explore one lead at a time, a quantum array processes the entire field of potential factors at once, turning a millennia-long computation into hours. The assumption of unbreakable math holds only as long as computers are forced to think linearly. As qubits scale, that assumption fails. Y2Q isn't just an update to our tools. It is the complete and retroactive collapse of the encryption we've used for decades. This brings us back to the petabytes of data being hoarded right now. What specific information is worth waiting years to see? The highest value targets inside those encrypted vaults are personal biometrics. This includes DNA profiles, retinal maps, and the fingerprint matrices used for device authentication. Biometric data is the most critical asset to lose because it is the primary link between your physical body and your digital identity. If a hacker steals your password, you can change it. Once the breach is detected, the old credentials become worthless bibliotheca. You cannot change your DNA. You cannot rotate your fingerprints or your iris patterns. When the Y2Q capability allows for the decryption of these archives, millions of people will face a permanent compromise of their identity, with no way to secure themselves again. The Y2Q countdown is a race to protect the future, but it also reveals a difficult truth. Our past secrets now have a visible expiration date.